Welcome to Rational Science. And hopefully everybody can hear me okay and everybody can see me okay. Okay, let me know otherwise there in the comments. What are we going to talk about today? We're going to talk about nothing. People say, Bill, you're always talking about nothing. Yeah, but nothing is very, very important, you know. We could say, though it's not mathematically accurate, that half the universe is nothing, you know. We got matter on one side and nothing on the other. And the part none of these people have ever figured out is the nothing part. Okay, that's unbelievable. After 10,000 years, they still haven't figured out what nothing is. And the main problem there is definitions. They never defined what nothing is. I mean, you want to know what nothing is, define it, and we're done. And so I guess they never learn how to define. That's where it all starts. Anyways, before I can get to that, I'm going to talk about comment someone made. And I want to discuss that a little bit so that we put everything in proper context. Okay, so here it goes. Fellow says the following. He says, look, I see your shorts on YouTube and I appreciate your efforts. However, convincing the public should not be your main objective. You are not the literate priest. We live in a very critical time. You can use scientific peer-reviewed journals. I get that. You can't use, these scientific journals. I get that, but you can make YouTube videos. Great. Target the so-called scientific-minded. He wants me to talk to the physics crowd, mathematical physics crowd, I guess he's referring to. Don't make fun of them. Just challenge them over and over again until they are forced to deal with you openly and honestly. I like that, openly and honestly, especially that part. You got the right argument, just not the right bait, my friend. Well, thanks for the recommendation, okay? I'm not sure I'm going to take it. I've been at this for 26 years now, since 1998, okay? And about 2008, I think I started with my YouTube channel, so that's 16 years there. And no, you're shadow banned to some degree. I have to believe that because the word doesn't get around, so there's got to be some of that. I have to accept that after so many years. That's one issue. The other issue is that, these people, these celebrities, they take up all the spots, all the spotlights, right? They hog up all the viewers. And so they don't give a chance through YouTube, at least, through videos, to reach the public, the general public. And so the general public always looks up the same names. They look at, Neil Tyson and Sean Carroll and so on, people who are popular today. And here you see them. These are the celebrities of today, okay? You can recognize some of them there, okay? And the issue here is that, all these people, they're clowns. And you might say, Bill, you're insulting them. Why are you telling us that they're clowns? And the issue is that they're clowns because they're not scientists. They're in the entertainment business. That's the issue. Okay, these people are stand-up comedians. They're there to make money on entertainment, keeping people who think these people are scientists busy thinking that they're scientists when they're not. What these people talk about is poppycock. Everything that comes out of their mouth is irrational, okay? And so, you've got this world out there where you've got all these mathematicians just telling people out there, what they think, their opinions, and their opinions are all alike because that's what they were told in college, that space is warped and a particle can be at two places at once and so on. That's what they tell you. And you say, that doesn't sound rational. And they say, well, yeah, we know. We don't understand it either. And they keep telling you that, but we know it all. We've got all these equations. And the problem is equations can describe some phenomenon. It cannot tell you the why, the cause, the mechanism that underlies such a phenomena if the mediator is invisible and intangible, which is a case of gravity, light, magnetism, and so on. So this is where the problem is. Here we are, 2,500 years after the Greeks dabbled in so-called physics, and we don't have any rational explanations for anything. That's where the problem is. And I've been fighting these people for a long time. And when I started out with my theory, I went out there to several forums. I think 3 of them at least, high-level forums, where some of these people talk about some of the quantum and general relativity stuff. And I got in there. One of them, in fact, was managed by people very close to Stephen Hawking. And I just couldn't believe the backlash. So, they were ridiculing me. And I went in there, not insulting or anything. I went in there saying, hey, guys, look, let me show you a different view, a different way of seeing the universe. And boy, all I got was, okay, I got beat up. I got thrown up. They throw all the rotten tomatoes and rotten eggs at me. So, I wasn't treated very well. And so, that's where it all started. And then as time went on, after 26 years, I can tell you for sure, without a shadow of doubt, these people will not listen to you. They're in a different world. They've been brainwashed to believe in math, and that math is the solution. It's the holy grail, so to speak, to finding out what gravity is, what light, or how light is, or how it behaves, etc. They think it's all through math. And so you're not going to go in there and tell them about qualitative stuff. They're not even going to listen to you. And the fact that all their magazines, all their so-called scientific magazines of physics and so on, the fact that all have the same format. In other words, you got to give them some equations. That's what they want to see. They want to analyze equations. And here you come in there and say, look, I'm going to tell you how this universe works. Forget about your equations. I just want to tell you how the universe works. No measurements, no equations, just this is how it works. This is what's out there. And they don't even allow you to publish that so easily. I mean, I was able to publish finally in IEEE, right? But it's like nobody reads it because it's out there in one little corner of the world, right? Nobody sees the paper, and so they don't read it and doesn't get around. And so this is part of the problem. The problem is you're censored on one hand simply by not being one of the celebrities that are talking to the public. That's one issue. People who have become famous, like some of these guys, Neil Tyson and Sean Carroll and so on, Brian Greene. That's one issue. The other issue is that they're not going to listen to you. They're not going to listen to you because they don't want to hear qualitative stuff. Qualitative stuff is stuff that they give to the public. They don't want to receive backlash. In fact, a couple of them say, hey, if you're going to tell me that quantum or general relativity are wrong, or that it's irrational and can't be understood, don't tell us that. We know that. We already know it's irrational. We don't understand it either. We do math, and we tell you what the math, in the best way we can with our words. We're going to tell you what the math tells us and how we interpret it, and that's what we feed you. But don't ask us to be, don't take the analogies so literally. So these are the answers you get, okay? And so you get the runaround. You never get an answer. They don't understand how this universe works, but they say they measured it, they got the equations to prove it, and that they know everything. And the worst part about it is that they're extremely arrogant. Extremely arrogant. That's why I have very little respect for mathematicians on planet Earth. I will never apologize to them. I think I'm more arrogant than them. I want to be more arrogant than them. I want to be the king of arrogance. When a mathematician comes to me with his arrogance, I want to shove it up his nose holes. And, you got these relativists here, and they laugh at the flat earth. And they look at what these guys say. Look, they've got the moon and the sun and the flat earth. Ha, ha, ha. And they laugh at them. They ridicule them. Okay, fine. Lots of us do that. I do that too. But what do they propose in exchange? Well, they propose the flat universe. This is what they propose. This is how they illustrate the universe. This is the idea they have. Or who knows what kind of idea they have in their minds, because they talk about the flat universe. They never define flat. They never define universe. They never define space. They don't know what space is, as we'll see today. And so you don't even know what they're talking about. They don't even know what they're talking about. So this is where it all starts. Okay, so yeah, this is the flat universe theory. Take it or leave it. Okay. So what do we have here? Well, these people have ended up with irrational explanations over the years. And you see something like this, for example. Where'd it go here? You see something like this. And they say, look, this is how gravity works, okay? You have the Earth going around the sun weighs down the what? The canvas? What canvas? What you're staring at is number lines, which they call dimensions. They're not dimensions at all. What they are is number lines, because that's all that mathematics deals with. And they say, well, this is the reason the Earth doesn't fly out of the solar system. This is what they illustrate. Okay, and you say, well, hold it, you're bending number line, you're bending time. What sense does that make? And they say, well, we don't understand it either. And besides, you're taking the analogy too literally. Well, hold it. I mean, here you're illustrating the notion you have in your brain, which is that the Earth doesn't fly out of the solar system because there's a warp wall of dimensions, of time, of space-time, or whatever. There's a warp wall that prevents the Earth from flying out, so the Earth can only, roll around or slide around. And so this is very clear what they're illustrating here. This is the mechanism of gravity they have for the cosmos. They say, these big masses like the sun, they weigh down the canvas, and the objects such as planets and asteroids and so on, satellites, moons, none of them can fly out because they've got this wall around them that they must travel around. And so another problem here is that, this Earth is, rubbing its shoulder against those dimensions. So how come it doesn't slow down? I mean, you would think if it's scraping itself constantly against the edge of this space-time thingy, how come it doesn't slow down? How come we that are on its surface don't get crushed, between the Earth and this space-time thingy? I mean, we should be squashed between them, flattened out. And so there's too many problems with this interpretation. This is absolute poppycock nonsense what you're staring at there. And again, the only thing they can offer you is to tell you, hey, don't take the analogies too literally. You're making too much of what we're illustrating. Well, yeah, physical theory you should be able to illustrate. You should be able to tell me a mechanism. If I tell you, how did you pull the donkey? You say, well, I tied a rope around the donkey's neck, I pulled from the other end, and you can see the whole thing. There's no problem. We understand it all just by watching, saying, okay, we know how the donkey moved from, the barn to the corral, right? We can see it there. And these people, no, they say, look, you're taking the analogy too literally. There it is. You gave me the picture of what you have in your mind, of what your equations tell you. That's not how the universe works, because there are too many problems with your illustration. It's not an issue of saying don't take the analogy too literally. It's that, what should I understand by your illustration? Why did they even take the trouble of illustrating it if they cannot put it into words? If they can't put it into words, they should just say, look, you want to understand this stuff, you just got to take math. But instead of saying that, they go on the talk circuit, right? They go on TV and they give you this show, this circus where the clowns, like Brian Greene and Sean Carroll and Neil Tyson, Bill Nye and so on. They go out there and they tell you, how this universe works. And it's all poppycock. And yeah, because these are clowns. They're entertainers. They're not in the science business. If they were in the science business, they would tell you, the theories of how it works. But they don't know how it works. So what are they going to tell you? Are they going to put an equation up there and say, look, here's the equation, Einstein's equation. This is how we derived it. Nobody is going to watch them. So they say, no, we got to entertain the crowds. And so they say, look, you got black holes and you fall into one, you get spaghettified. And man, and people say, hey, I love that, flashy stuff. They show the asteroid being strung out, and so on. It's all show. It's all nonsense, poppycock. None of that has anything to do with the reality out there. None of it. And you can imagine if overnight someone were to overthrow all of mathematical physics, well, that would 100 years of research, mathematics, equations, measurement, etc., would go down the drain suddenly. It would be a catastrophe throughout the earth. In all think tanks out there, all universities, all of it would be overhauled. So let us hope, for the sake, God, please don't let that happen, because I don't know what would happen to all the mathematicians. They would be hung, each one of them at dawn. Okay, so you saw what gravity is, and so now we're going to ask, a prominent fellow here, what is gravity? I mean, we just saw what gravity is, right? It's the bending of space-time, of these number lines, and very straightforward what gravity is. So here we have one fellow, and he tells us what gravity is. Listen carefully, okay? Here it goes.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know. I don't know. I don't know. I don't know. What it is, I don't know.
So what is gravity? He says he doesn't know. This is one of the clowns that is in the entertainment business. And we just saw what gravity is. It's the bending of space-time. Why didn't he just say that? It's the bending of space-time. Well, because nobody understands that. Because space-time is a bunch of coordinates, as they say. It's a bunch of number lines. That's what it really is. And what kind of explanation is that? There's no explanation there whatsoever. So they can't tell you how the universe works. They have no idea what gravity is. And gravity has, stumped them now for thousands of years. But the worst part is that they're so arrogant. Here you have one fellow, and his name is Sean Carroll, and he's going to tell us, what's out there, all these fields, as he calls them, that are out there. But I want you to listen to his tone. He's so arrogant. He's so cocky. He knows it all. He's a mathematician. He studied 10 years. He knows all those equations. He's super arrogant. And what's so funny about it, really, it's ironic that, these people are talking absolute poppycock. If tomorrow they get caught, in their lies, I don't know what's going to happen to them. They're going to be lynched. So here goes. Listen to Sean Carroll tell you about fields, WC fields or something like that. Here it goes.
Is light, for example, a particle or a wave? A wave is sort of a vibration in a field. So what's the answer to this? This is the answer. It's fields. It's not a mystery. They always tell you that question. They never tell you the answer. You need to stop thinking of the world in terms of particles. You need to start thinking of it in terms of fields. There are particles in the world. No, there aren't. That's the secret that we physicists have never told you, but here I am, I'm going to tell you right now. The world is made of fields, but quantum mechanics says when you look at the world, you don't see it directly. So the reason you think that there are particles is because there are actually all of these fields filling empty space. At every point in space, there's dozens of little vibrating fields in front of you. But quantum mechanics says that when you look at the fields closely enough, they resolve into individual particles. Quantum mechanics says you look at that light very carefully and it turns into individual particles called photons. Photons are the particles that you see when you look at a wave in the electromagnetic field. The reason why light resolves into photons is because quantum mechanics says that when you look at it, that's what you see. The relationship between particles and fields is that fields are what the world is made of, particles are what you see. So the atoms in this table, the electrons, the quarks, the protons, these are all vibrations in fields. There's a quark field that is vibrating. You look at it, you see quarks. There's an electron field that is vibrating. There's a neutrino field that is vibrating. There's a gravitational field that is vibrating, and so on and so on. That's quantum field theory. It is the very heart, the central organizing concept of modern physics.
Okay, so it's all fields. But I hope you listen to his cockiness, his arrogance. It's just outrageous. These people say they know it all. When you ask them how this universe works, they say, well, we don't understand it, but we measured it, and here are the equations, so we know it all. And then they can't answer a single question. And so it's all show. It's all entertainment. These people are clowns. They're not scientists. Not what you see every day in YouTube or on TV or wherever. And here you get an example, some idiocy that came out this week. I mean, do we really want to put up with this for the rest of eternity? Here, look at this. It says, scientists say wormholes are secretly altering our reality. Wormholes are affecting your reality. So, they have articles like this in prominent magazines, right? That supposedly represent the scientific world. And this is the type of information you get every day. This is freely available to everyone. And so this is, you got to think about whether you want to keep staying in this, mental institution that we call mathematical physics that gives you all this garbage. Where they can't answer a single question and so on. So yeah, I've been fighting these people for so long. And, I'm going on 72 this year. I can't even walk right now. My left leg, left knee is swollen. So I probably need another operation. I've had like 6 or 7 of them. And so, I don't have anything to lose by ridiculing these people. In fact, that's what I believe in. I think that right now I'm just going to have fun for whatever time I've got left. I don't think I'm going to reach the age of 90. Please don't let me reach the age of 90, And I don't even know if I'm going to make it to 80, right? But, this is what I think. I say all these big name celebrities spit up poppycock and garbage, okay? So there's no peace treaty that we can sign. Okay, they're never going to listen to me. They haven't listened to me in the past when I went to them, Clark Kent-like, mild-mannered and so on. They're never going to listen to me. So it's not going to happen. I'm not going to cater to them. I'm not going to treat them nice. It's the other way around. I'm going to bash them as much as possible, especially ridicule them, because I want that to be left when I leave. When I leave, maybe some young people might take over and they might carry their vengeance out. Okay, that's all I can hope for. I'm not concerned about convincing the establishment. Either they prevail and humans go extinct in utter ignorance of how this universe works, because they have the unlimited funds pouring in, they have resources, control of the press, think tanks all over the world. I can't fight all that. I'm just a little guy compared to them. I'm a little ant fighting a herd of elephants, right? Or they are utterly destroyed overnight. If it happens that all these people are, the emperor is shown to be without clothes. Well, I don't know, 100 years of quantum mechanics, relativity, and we can include string theory there as well, all go down the drain suddenly, overnight. And all these mathematicians are ridiculed out of existence. And that's my only hope. So I don't hold it back. The way I look at it, if you can't beat them, well, then you ridicule them. Okay? So, can't beat them, ridicule them. That's the way I look at it. Okay? And at my age, After all of what I've done out there, I'm not concerned, Quite the contrary. I'm going to have fun with this all the way to the end. Okay, so I'll take that recommendation with a grain of salt. Okay, grain of sand, whatever. Okay, let's go into nothing. Let's go into space. Or did I say that right? Yeah, space is nothing, right? Well, some people say we don't know. They think it's something. But let's start with what space looks like, okay? So here, let me show you what space looks like, okay? That's what space looks like. Okay, so if we get rid of all the matter, all the radiation, energy, fields, or whatever you want to put in there, if we get rid of all that out of the universe, this is what you would get. You would get space. Nothing. Void. And it looks quite black, Yeah, that's the color of nothing. Black. Now, that doesn't give you a right to go to a African American and say, hey, you look like nothing. No, that's not what I'm suggesting at all, okay? But yeah, you take light and everything out of the universe, I guess it would look dark. I don't know why God made it dark. He could have made it white for all we know, but he made it dark and black, okay? So take that as you want to, okay? Okay, so where all this stuff come from? Well, we've been studying space, empty space, at least since the days of the Greeks, who filled it with ether. They had this space which they imagined out there, and they said, look, it's all full with stuff. But of course, they knew very little about what was out there, in the night sky. And so all they could do is give you an idea, or give themselves an idea of what was around them. They said, look, there's something here. I'm breathing it. I don't know what it is. It's invisible. Who knows what it is? And so they say, well, we'll call that air. Okay, so this air is there, and my hand is here, and the table is there. Okay, and so the issue was, look, every bit of space is covered with something, has something in it. There's no such thing as empty space. Okay, what does that mean? Well, it means that there were two versions. One version is that there's no motion, nothing moves. And you say, well, what do you mean nothing moves? Parmenides and Zeno talked about that, the Eleatics, these two fellows here. And by the way, even though they were Greeks, they were in the southern part of Italy, okay, which was a Greek colony. Okay, so these two fellows, and a couple more, they talked about there being no motion, not only no such thing as empty space, void, right? But no such thing as motion. You say, what do you mean? I think I'm moving my hand. Well, you think you're moving your hand. You really cannot be moving your hand, because your hand would have to move into void. Okay? So there's an empty space here. You move your hand into the empty space. Then you have motion. But that doesn't happen, because what's really happening is that void doesn't exist. So you're moving your hand into a region that doesn't exist. So does your hand disappear when you move it there? So that more or less, I guess, was their line of reasoning. They were saying there's no motion, which was a scary thought. At least that's what the translators got out of the Greeks, Parmenides and Zeno today. And that's what some of the people like Aristotle criticized of, Parmenides and Zeno. Now, Aristotle, he had a little different idea of that. He said, look, there is such a thing as space. There is no such thing as space, but there is motion. But he was referring to there's no such thing as empty space, a void. Okay? There's one object moves and another comes in and takes up its place. Okay, so he had this notion of what is known as the 16 16 square puzzle. And what it is, an object moves and another one immediately goes and takes up its place. That's more or less the idea Aristotle had, of how this universe works, at least down here on Earth. Says, look, for you to be able to, there is motion, and for you to be able to move, there's got to be a space for you to move into. And what you're doing is displacing something else. In this case, these things are moving, but then one other question is, what is moving them, right? What is moving one, for example, the 7 there that just moved, what is moving it to the side? And in the case of humans, we can all figure that out. But in the case of inert matter, it's not moving. And so the only way it gets to move, if you move it or something moves it, maybe an earthquake or whatever, moves it, and something else immediately occupies its space. Okay, it could be air, it could be water, it could be anything. And so this is the issue. They had this notion of what empty space was really like. And they dabbled about, for hundreds of years in the days of the Greeks, back and forth between the so-called philosophers of different regions, and they all say, no, it's like this, and the other guy say, no, it's like that. And the funny part is that today we have the same ideas. Relativists and quantum mechanics, they all inherited those same ideas. They haven't discovered anything new really today, because they're debating the same issues that were debated 2,500 years ago. Whether there is anything such as space, and whether all of space is covered, completely filled, and then whether, what is motion within that. So all these same questions are being asked today. So nothing's happened. 2,500 years, we haven't made a single inch of progress in our understanding of space. The mathematicians, obviously, not rational people. Rational people say space, it's nothing. We're done. That's how easy it is. But for irrational people, they're still debating in circles. Is there such a thing as space? Is it filled? Is it infinite? You've got all these questions. And, the Greeks, they were studied for hundreds of years. You get to the 17th century when some people started dealing with these issues again. Here you have Descartes, and he had this notion that there is space out there, but all of space is filled. But it's not filled with particles, it's filled with these vortices that he had, these swirls that he had in mind. He says it's all swirls. But you can see, very important here to show that one swirl is identified from another. They're not all, a single flowing blob. It's like here's a swirl, there's another one. They're all delineated by that perimeter that each one has. Okay, so we want to know what those dark lines that separate all those swirls are. And you have to think about that as space. I mean, what else are you going to call it? We call it space. So even in the best of case, if we accept his hypothesis, his assumption, what we have is that we have to identify the black lines that surround each one of these vortices, okay? And we call that space. So there is something called space. We can't say, well, space doesn't exist, or however you want to say that. There's matter and there's space. Space is not the same quality, of the same nature as matter. Period. We're done. And there it shows it. Whatever gives contour to that is what we call space. Okay. And his ideas were carried out, again, they all believed in the ether, meaning the ether fills out all of space, whatever the ether was. A bunch of particles, some saw particles swirling around as Descartes did. You get to the 19th century, you get George Stokes, which took up, essentially, carried from Descartes, and he came up with these swirls also. He had these ideas that you had these vortices out there as well. So, they just kept with the same ideas over and over and over again. And apparently the ether died down towards the end of the 19th century, but it didn't die out completely. It just got, they gave it new properties. That's all that's really happened. And because they gave it new properties, they changed the name, because they say, well, ether is now tied to this background that exists out there that supposedly was the waving of light, and not a good idea. Let's get rid of that word. And so by the first quarter of the 20th century, the ether was almost dead, if not dead completely. Even Einstein was vouching for the ether, just giving it different properties than the one that Lorentz gave it. But this ether was filling all of space, and even Einstein said, general relativity, space-time without ether is inconceivable. And so, you had to have this background, this ether that filled all of space. It was space, but space with properties. That's especially what Einstein was referring to. He said, there's this ether. What do you mean by ether? Well, this ether fills all of space. And what do you mean by that? Well, the space has these properties, these physical properties. And that was the ether. That's what they talked about when they talked about the ether. So exactly how they imagined it, a bunch of particles there, vibrating and so on. But they said there is a background. We can't get rid of space. There is space there, but they could never define what space is. They could never define ether, for that matter, as well. And so this is more or less an outline of what happened. You have what the issues were regarding space. This is the irrational discussion throughout history. You have space as a container. That's what everybody, even most people, think about it in today, right? They think it's a container. And within that container, you have either ether. Some people say it's ether. Others say, no, there's no ether. There's all these fields. There's all this energy in there. They talk in very abstract terms. And so they're putting concepts in there. So they're filling the space, this container, with concepts. And that's what they're going to deal with. But they're treating the space itself as a container, as something. And we have a problem because they never define what something is, what nothing is, space, right? So there we define it, space, that which has shape, nothing, objects or something, right? That is that which has shape. Nothing is that which doesn't have shape. Very straightforward. Objects have shape, space doesn't have shape. One is the antonym of another, space and objects, nothing and something. So now we're done. Now we have a language that we can all understand. It's straightforward, black and white, right? We can all distinguish something from nothing. And so you have these questions that pop up. Is space infinite or is it finite? And if it's infinite, it's not a container, it's not an object, because something is that which has shape. So if it's infinite, it's not an object. And if it's finite, hey, you're the proponent, you're the guy who's presenting space as a thing, you have to draw it. Tell us what you have in the back of your brain. What does it look like? We don't care if you speculate it. Draw a circle or a globe or a cube, whatever you want to draw. We don't care, but you have to draw something because you are proposing space as a physical object, as a container. So you got to tell us, first we got to see the whole container from a bird's eye perspective, as if we stood outside of space, right? Because space is there in front of you, right? All of space, the finite space, right? And then, of course, if you do that, then you got to tell us what's outside of it, what contours, what gives contrast to space, because you're treating it as a physical object. You're treating it as an ocean, as a medium. Okay? You're treating it as a medium. But even a medium such as the ocean has, its borders. And what are in those borders? Well, what you see there is, the banks, the ground that's giving it shape. And so contours, and so on. And so the issue is you can't have, you either have infinite space or finite space. Finite, you got to draw it. Infinite's not an object. And so you still have to tell us what you're talking about. In fact, if it's infinite, meaning that it has no shape, it's a concept. Very simple, because only concepts have no shape. Okay, and then the question is if it's completely filled. And again, I don't know how you can say it's completely filled if it's infinite, if space is infinite. If it's completely filled, it would have to be, space would have to be finite. That's one issue. The other issue is that, I work with vacuum quite a bit, and you have these chambers and you suck everything out. And you have different levels of vacuum within the chamber, okay? And so when they say, all space, there's no bit of space that is not filled. Yeah, but there's different fillings. It's not the same thing if you put gas in your tank halfway or full. or a quarter or whatever. What's the rest called? We call it space, empty space, right? And that's the issue here. The issue is if you take a cube of space, 1 cubic meter of space, right? And you vacuum like in a vacuum chamber, and you vacuum stuff out of there, especially water and air and so on. You take stuff out. Well, you got different levels of vacuum. And that means that when you pull stuff out, you got what? You got more vacuum, more space. So you can't just say all of space is filled. No, there's different levels of filling. And if you have almost absolute, vacuum in there, what is that vacuum? What is it? What is that vacuum filled with? Nothing? And again, you have to define these terms to be able to talk intelligently, and they never do that. They never did. And that's where the problem is. They go around in circles because they don't define their terms. The key, the strategic terms with which you can make your case. Okay, and so, but if it's completely filled, well, is space not a different thing than the thing that fills it? If you're going to put garbage inside a tank or a container, the container is different than the garbage you put in there, hopefully, right? So you still have to identify what that container is. You got to either define it or point to it. One of the two. If it's an object, it's a container, you point to it. If it's a concept, you define it. Very simple. Okay, so you do have to define the word space before you can do physics. They never did. And you have these contrast, backdrop, background. What separates each object, because you have the 16 square puzzle. What separates each square from another one. Otherwise, it would be all a single blob. Okay, and they're working towards that right now with this quantum field theory. But the issue is that if you separate one from another, there's got to be something that gives contrast to those two separate objects. And we call that separating line, we call that space, right? Again, if you have one of these particles come into reality, like in the quantum virtual particles, what does it leave behind? Here you have this particle come into reality because they say it started to exist. Right? It came in from the void, whatever the void is. Came in from empty space, whatever empty space is. Okay, so what did it leave behind? A hole? It was there before it came into our world, to the world of the existence. And by what mechanism? Was it pushed? Was it pulled from us? Or was it pushed from the vacuum? So, all these questions have to be answered, Here you have the relativity version, of space, of what they think space is. They think it's a thing, a medium of some kind, and they fill it with this thing called space-time. And to put it out of your reach, they say it's four-dimensional, you cannot imagine it. Okay, great. That's a great way to start your dissertation. You can't imagine what I'm going to talk about, so don't even try. Let me tell you a little fable, a little story. That's the way they start all their presentations. And it's made of dimensions, which are not dimensions, they're number lines, okay, as I discussed a minute ago. So yeah, it's not made of dimensions, not dimensions of physics, meaning length, width, or height. It's made of number lines. That's the general relativity dimension. And then you have this space-time grid, I showed it a minute ago. Here it goes again. This is what it looks like, the space-time grid. And you say, what am I staring at? What is this thingy that is bending there and that's going, and that the Earth is going around over and against? And what you're staring at is a bunch of number lines that the mathematicians bend because that's what the equations tell them to do. And with this, they try to make a picture. Talking physics now, they move into physics and they say, let me tell you how this universe works, and the Earth is rolling around these bent number lines. And you say, well, hold it, that doesn't make any sense. Yeah, we don't understand it either, and don't take the analogy too seriously. And that's all you get from these people. And it doesn't ever get any better than that. Okay, so what can I tell you? This is where we're at today. So it's up to you to see if you really want to continue listening to these folks, these mental people, who've been brainwashed in college to just tell you this because this is what they were told by their teachers through authority. They say, we prove it in, you got to accept it. If you want to pass the course, you got to repeat like a parrot. And so the guy said, okay, I'll repeat like a parrot. And then he comes out of school and he said, hey, I got my PhD, 10 years in school. Now I'm going to repeat like a parrot what they told me. And that's all it is. It's just parrot telling parrot over the decades. One generation after another. That's what's been happening. And so here you have, one is the space-time grid. The other one is that mass is warping a number line, and the time number line specifically. It doesn't make any sense to say you're going to warp time. That should already be a red flag for anyone that what these people are doing is totally irrational. You can't say that the reason the Earth doesn't fly out of the solar system is because time is warped. You say, they don't say that, Bill. Yes, they do. They went out there with the Gravity Probe B, NASA. NASA, you heard of NASA? It's a government institution, formal, scientific, blah, blah, blah. They sent a rocket out there, with a probe. And what they found is that the gyroscopes that were on that probe were dragging, like when you drag a dead cat or whatever. They were dragging, the gyroscopes were dragging space-time. They were dragging time around the Earth. That is the conclusion of that almost $1 billion experiment. So don't tell me that general relativity doesn't say that Earth doesn't drag time around. Yes, that's exactly what they proved with that experiment. And then the explanation for why the Earth doesn't fly out of the solar system is that space-time is warped. That's space-time. Let's forget about space. We got time is warped, right? What does that mean? It means that you're bending a number line. So yeah, these are the answers you get, and then they say, well, we don't know what gravity is. Like Neil Tyson said there, he doesn't understand gravity. He doesn't know what it is, but they go in there and say, oh, but we can tell you that, what gravity is. Gravity is the bending of space-time. And so they just keep going around in circles. That's all they do. And then at the end of the show, the final closing argument is, oh, they don't take the analogy too literally, or they laugh at you for doing so, for taking the analogy too literally. You really believe in that analogy? Well, you presented it. That was your presentation. What am I supposed to believe in otherwise, Well, you got to study math. What does math help me? I mean, I can see there what your idea is, and it's total nonsense, total poppycock, okay? Okay, and how about quantum? Well, here's the quantum version, okay? First they have quantum uses only the ether, okay? Quantum hasn't gotten rid of the ether, just revived it, and will never call it ether, because like one fellow says, Laughlin, Nobel Prize, he says, it's taboo. The modern concept of the vacuum of space, confirmed every day by experiment, is a relativistic ether. But we do not call it this because it's taboo. Yeah, you don't want to call it ether because, that's a bad word. So people will think you're crazy. They'll call you a crackpot or whatever, right? And so, yeah, the quantum space, it looks more or less like this. I try to make a picture of it. Here it is. That's what it looks like. It's a trash bin. It's a trash yard. Okay, it's got all this garbage strewn around. Okay, so there you see what vacuum of space is. If you had the eyes of God, you would be able to see all the energy and all the fields and all the garbage that these people have in their virtual particles. Okay, all that stuff's in there. Okay, so that's what it looks like. I wanted you to see what the quantum, and not only the quantum, that's also the relativistic ether, by the way, vacuum, so-called vacuum. The false vacuum, they call it, because it's false. Okay, and so what's the issue? The issue is what they've done. Maybe this is new from the Greeks. The Greeks didn't think about that. They have all these particles come in from the void, but they don't come in and stay here, like if a rabbit popped out of nowhere and just landed on your hands. That's not exactly the way they see it. They say, look, this particle just blips into our real world and immediately, below the Planck time, so that They can't put their probes to measure it below the blank time. It just goes away. You say, well, how did they know that if they weren't able to measure it and so on? Well, what they have is they have an equation. Remember, all these people are just mathematicians, nothing but. And they have an equation, and they need to fill in something. We're missing some energy here. Oh, very simple. It's energy from a virtual particle that pops into existence just to make our equations come out right. For that split second, lower than the Planck time, so that the guy can't put the probe to measure it, and the guy goes away, and goes back to being part of space, time, or space-time, who knows? And so that's the answer you get today, right? And so quantum space is completely filled with energy fields, and especially these particles. They're called virtual particles. And the question is, are they particles? And the answer is no. These particles are just values that they put in an equation. And they're missing a little value there, and they put it in there, just like the neutrino. Neutrino is just a value that they're missing. Okay, they have this reaction, right? And it spits out stuff from the atom. They say, well, here went the neutron, and here went this proton, this other one, and we're missing a little bit of energy that we can't account for. And that's the neutrino. They say, oh, it doesn't have charge, so we'll call it a neutrino. Not a neutron, it's a neutrino, a little neutron. Okay, so they have all these answers for what's out there in space that they can't see. And they see in the experiment, we show that these particles pop in from the void. Did you take a snapshot of it that you can show it to me? No. But mathematically, we showed that there's a bit of energy we cannot account for, and we'll call that, the virtual particle. That particle comes in from the void and then immediately leaves this prison, this hell of a prison. Okay, and they call them quantum fluctuations. Okay, they say that all these things are vibrating out there. It looks more or less like this. Okay, here you see it. That's what they look like. That's how they imagine them. That's what they illustrate. But you can see that you can delineate. You can have a perimeter around each one of those. So each one of those is separate entity, and they're all discrete. Because when they come in, they're suddenly discrete. Maybe they blend for a second with some others, particles there, whatever that means to them. But they have these particles coming in, and they are discrete. That's important to memorize that, okay? Keep that in mind for a second. Because what you're going to see is something totally different, what they're moving into, what they're changing everything to, okay? It's important to see that. And So the issues there, right there, where you see it, these particles should be islands. Okay, it means they're completely surrounded by empty space. And so they're filling space. You should have a dividing line from another particle, and that dividing line we'll call space, because something has to give contour to each particle all around. So what do they have? They have this field, which they just threw a bucket of paint and painted all of space with this paint, right? It's covering everything. It's like water flooding the entire universe, right? This medium. And what they're going to do, they're going to create this fieldy thingy, whatever field is, and they're going to create not islands, they're going to create peninsulas. Okay, that's where the problem is, because now they've realized that they can't work with particles. Okay, they have to work with peninsulas. And the peninsulas are these vibrations, local vibrations that come out of the fields. And you have the gravitational field, you have the quark field, the muon field, the pion field, you have electron field, and so on. They have all these fields, they're all superimposed on each other. You have the graviton field on top of the light field, the electromagnetic field, and so on. They're all superimposed. And somehow they have these vibrations, and what comes out of these vibrations are these peninsulas, and these peninsulas somehow send peninsulas? I don't know, because you can send a particle, if it's a discrete thing, how can you send a peninsula? Well, they transfer energy somehow, and that energy obviously is a block, a quantum of energy, meaning a particle, as they call it, and that's what is transferred to another particle, and those interactions produce attraction, who knows how, right? Because there's no mechanism there, they just say it does, because positive attracts negative. Oh, great, I learned a lot with that, and so on. The explanations are all ridiculous. They're not even ridiculous. They're totally irrational. They're laughable. Okay, and so here you see space particles moving, right, in that region, right? So let's assume that's what they're imagining, that all of space is completely filled with particles, right? So the particles are moving, right? And now one of these particles, these virtual particles, pops in from the void, right? Blick. Okay, so we freeze the frame. It pops in so swiftly that it goes back to covering that white hole that you see there, okay? But for that split second, there's a hole there, hopefully. And the question is, what is the white stuff if not what they call empty space, right? So we still have to define space if we're going to bring virtual particles from the space environment into our real world, from the inexistent to the existent. Okay, so we have a problem here because they still have to define, what this virtual particle is. Does it make up space while it's still out there? Does it leave a hole when it comes in here into the real world? And so these are the questions they have to answer. And of course, no one does answer these. They just tell you they do. We proved it in the lab, and don't take the analogy too seriously. Okay? And so they exchange these discrete particles. So who knows how they do it? And here you see a notion of this peninsula thing that comes out of this space fieldy thingy, whether field is the same thing as space or not. Apparently it is. They're synonyms. It's like fields cover all of space and they're just vibrating out there, fill all of space. That's the way they want you to think of it. But they can't draw it. They can't illustrate what they're saying. And here you see a two-dimensional version of that. You can see all these particles. They're peninsula. You can see they're stuck to the vibrating field, right? And I like the fact that they have the virtual particle and the anti-particle at opposite ends. I like that, What is positive, what is negative? Well, one is up above the field, the other one's below the field. And they say, and so you might say, Bill, you're making fun of these poor fellows. They work all day long doing these equations. You're gonna make fun of them, ridicule them. Yeah, I mean, look at their baby pictures. Okay, is this science what they're showing here? And if it's not science, why do they try to illustrate their mathematical concepts when they can't? They should just say, look, we can't illustrate what we're talking about. Period. We're done. But these illustrations, they're ridiculous. And here you have the same thing in fast motion, right? In dynamic version. And here's our good friend Arvin Ash. And he's illustrated all this stuff because they're moving into quantum field theory. They forgot about quantum mechanics. You say, no, they're still with quantum mechanics. No, they're not. Let's make sure that that's clear. They're no longer into particles. Okay? They forgot about particles. And what did Sean Carroll say? No more particles. Now it's fields and vibrating fields. And the particle is a vibration of the field. So it's a lump, a little peninsula that comes out of the field. And this is what Arvin's going to illustrate for us. So watch carefully, more than listen, watch carefully. But he'll try to explain how gravity does its attraction with these fields, the gravitational field. Here goes, okay? Watch carefully.
One can attempt to treat gravity as a field analogous to the electromagnetic field. An excitation in this gravitational field would be the graviton, just like an excitation in the electromagnetic field is the photon. The exchange of gravitons between two particles would result in attraction. This is analogous to the way an exchange of photons results in electromagnetic attraction between two oppositely charged particles.
So there you see it. They have all these fields, these peninsulas, and they fill space. What is space? We still don't know because they haven't told you what it is. They just say it's full of what it's full of, not what it is when it's not full. I want to know what space is when it's not full. I want to know if it's infinite or finite. And what I mean by that is that the person giving the presentation, I don't care which one he chooses. He can choose the finite space or the infinite space. He can choose either one. But he's got to choose one and give his presentation with one of those. If he's going to make it finite, start with a picture of your space because Space, because an object, a thing, a medium is that which has shape. Okay, and so he can't just begin talking and say, "Oh, space, it's finite." No, it's a thing. No, it can't. You got to illustrate it. And if it's infinite, well, it's a concept. You defined it. You can't say it's a container then. Okay, because a container is a thing. Okay, so all those things have to be clarified before the guy gives his presentation, and he can choose anyone he wants. I don't care which assumptions he or she selects, but he's got to choose one of those. Okay, if we want to understand it, if we want to follow his presentation. And you can see what these people are doing. They're just illustrating stuff that makes no sense whatsoever. They do it in 2D because they can't even imagine it in 3D, let alone in 4D, like general relativity. And so they have to give you whatever they can. And they're trying to illustrate something that is unillustratable. It's impossible to illustrate what they're discussing. Therefore, they have no notion of how anything in this universe works, above all gravity. And all they can do is say, look, we proved it. Here's the equation, and don't take the analogy too literally. And that's all we're stuck with today. So all I can say is, we need to get rid of all these people. They're clowns. They have nothing to do with science, nothing to do with physics. All they are is clowns. They're entertainers. They're in the entertainment business. And that's why they get all these hits, because people out there don't know any better. And they say, well, what do I know about all that stuff? And I just want to listen to this guy because he seems to know what he's talking about. He's got a PhD, got 10 years at the university. Okay, so I'll listen to him, get my shot of science for the week, and they follow these guys. And none of these can tell them anything about how the universe works. But then what happens is the overall ideas the general public has out there is that, the universe works the way these people tell them, with black holes, wormholes going to another universe. People just live in this fantasy world, and they have this false sense of security in science of what really is science and what really is out there, how this universe works.